Yes, sir.
Very good. Yes. So the remaining portion of your networking revision is like first is about a protocols. In generally earlier days, these protocols I will explain inside your OSI model application model only itself. But now I just want to separately, I want to see protocols and port numbers. Okay, first of all, protocol. What is a protocol? Protocol, some people say set of rules. Okay, set of rules. But they didn't say what rules it is. Okay, so my definition of protocol is protocols defines what type of communication, what type of communications. Okay, so for example, your web related communication, HTTP protocol, mail related communication, SMTP POP3 IMAP related protocols. Okay, or file upload download FTP protocol. So different protocols for different types of communications. So what it is? Different protocols used for different types of communication. Different types of communication. Okay. Now we'll see some of the protocols because it is not a tried class. Already we have discussed these things. Some of the protocols and their port numbers. Again, there is a 65,536 port numbers are there from 0 to that many port numbers 0 to 65,535 port numbers or 36 port numbers are there. Okay, but around that one 1024, 1023 port numbers, okay, are dedicated port numbers. Some are service based port numbers. Some are like a user defined port numbers also there inside that total one. But point is not that one. Point is the port numbers are representation of particular protocol or service. Port numbers represents certain protocol or a specific service. That is our port number. Okay. So every protocol has a port number. Okay. So system understand actual inside of system while it is sending data. So it will understand based on the protocol and their port number wise only. Port number wise connectivity. Okay. So here already we discussed the protocols and their port numbers. I will tell protocol, you will tell port number. Okay. Ready? HTTP, HTTP, yes. These two protocols for web-related communication. Web-related communication. HTTPS, okay, is HTTP over SSL, or you can say HTTP secure, okay, secure encrypted type encryption. So data is encrypted. You know, in your WhatsApp, you got it this end-to-end encryption. Same thing with the HTTPS. HTTP, so direct data, but HTTPS or SSL, it works, means secure socket layer. Okay, so that is secure your HTTP data using encryption. SSL means secure socket layer. Anybody tell HTTP port number?
80, sir.
80.
Very good.
80.
HTTPS.
443.
443. Very good. Okay. Next is FTP. File transfer protocol. What is the purpose? To upload or download a file from FTP server. Port number?
T20.
Very
21.
good. 21. SSH, Telnet, RDP, remote connectivity. SSH give encryption type of connectivity, encrypt. So all are used for a okay. So data is encrypt while you are accessing remote access. So that is SSH. Okay. In Telnet also CLI based remote access, SSH also CLI based remote access, but SSH having encryption, data is encrypted. Yeah. Port number
22.
22. Very good. Telnet 23. Okay. RDP 3389. RDP is a GUI based, so remote GUI. So they can exactly say remote desktop, remote desktop access. So it is GUI based, mainly used in Windows systems. SSH for remote access and CLI and encryption. Remote access, CLI. Mail communication. What are the protocols? Mail communication. SMTP, POP3, IM, AP, version 4. SMTP, port number.
25.
Very good. POP3,
110, sir.
110. IMAP, version 4.
143.
143. Very good. SMTP, so again, mail communication, usually sending mail purpose. Okay. To send mails. To receive or retrieve mails. Receive or retrieve mails. Okay, incoming type. This is outgoing, this is incoming. Mail communication completed. TFTP. Port number is 69. So remote configuration, upload or backup purpose. Okay, you don't worry. If you forget that one also, no problem. Okay, but try to remember that's okay. Otherwise, you can do it. Yeah, and two important DHCP, DNS. Domain host configuration protocol. Port number 67, 68. DNS.
53.
Very good. 53. It's a name resolution. It means name to IP concept. So that is a name. So for example, you open facebook.com, but you should communicate. So we said that, so all communications by IP address. Your laptop having a already IP address is there. Your mobile phone already IP address is there. Your desktop already you have IP address. Manually or automatically it is IP address is there. But you should know the destination PC IP address. Destination IP is required. So you open Facebook.com, but you don't know the IP address. Then what system will do? System go to the DNS server, find the IP address of your Facebook.com and give it to you. The DNS will give the IP address of Facebook.com server. Now you can able to communicate with the Facebook.com with an IP address. That is what is DNS, domain name system. Then DHCP. Anybody will tell what is DHCP?
Dynamic Host Configuration Protocol.
What DHCP server will do?
It will assign the IP address.
Very good. Assign or configure IP address to client devices. Not devices, no problem, anything. Kerberos, LDAP. These two are for authentication purpose. Kerberos and LDAP are used for authentication purpose. Kerberos is port number is 88 and LDAP is 389. Purpose is authentication. Authentication purpose. Okay. Like you log into gmail.com, username, password. So what is that backend will have? Authenticate. It authenticate you whether you are your name and password is correct or not. Then it is allow you to access. Authentication means verification of identity. Authorization means okay, you are allowed to access or not. Authorization means permissions. Okay, access, providing access. Okay, mainly this Kerberos protocol used in a Windows Active Directory. LDAP, same authentication and authorization. Different authentication and authorization protocol servers are there. So used in both Windows and Linux, Unix system. What I'm missing? SMTP 161, 162. It's mainly for monitoring purpose. Monitoring devices or services, applications. Okay. Mainly used in monitoring purpose. Okay. So you can check this device status details using monitoring.
Sir, it's SNMP, right?
Oh, yes, right. I actually very good. SNMP. Simple Network Management Protocol. NTP, this is what I forget. 1, 2, 3. Time synchronization process. Time synchronization. Okay. So these are the different protocols and port number. Not only this, there is so many protocols and there is so many port numbers also there, but regularly used protocols and port numbers. Okay, so some are able to remember, some are may not right now. At least next time, what you will do, guys? The best thing is by heart. Okay, best thing is about to by hearting. It's not about. It's not that point. It is what I'm saying. It is. You can remember very quite easy based on what services based on that. What is regularly using? We are using web communication, right? So web communication. Okay, web-based communication. So you are accessing through web. Okay, so it is HTTP, HTTPS. Your communication, mail communication you are doing. It means SMTP, POP3 or MAP, three protocols. Remote access, SSH, Telnet, RDP. Okay, so you need an IP address, so DHCP. You want someone's IP address, you know the name, but you want, you know the name, but you want their IP address, DNS services. You log into your machines, log in, log out, log in. Authentication protocols, Kerberos and LDAP. Okay, so you're setting a time. So the time it is showing in the bottom, right? From time server. Okay, so by default in our system is time.windows.com is our time server. Time.windows.com is our time server. Okay, our default NTP server configurations. See, all are completed. Okay, except one or two. Okay, this is used to file upload and download purpose. Okay, so uploading file to your FTP server and download file from FTP server. Okay, web access, to access a website. So you need a HTTP. You want to access a website with a secure HTTPS. Okay, so as I said, the port numbers representing of protocol or certain services. Just for fun, I'm adding, already we discussed this one, just I'm adding these things also. Okay, again, once again. For example, you want to connect MySQL server. It's a database server. Remotely, you want to connect it. So the support number is 3306. Okay, you have Oracle. DB server is, database server is there. 1521. So for a remote connectivity, that is called DNS listener port number. Okay, like a different protocols for different service purpose also. For different port numbers are for different service connectivity. I have a Tomcat. Tomcat is a web application server. You can deploy web applications on a Tomcat server. By default, it is always use a port number. By default is 8080 port number. Okay. So like that, guys, different protocols, different types of services having different port numbers also. Just for an example, I give it. Okay, guys, clear about port numbers, protocols, what is meant by protocol? Everyone?
Yes, sir.
Yes, sir.
Yes, sir.
Very good. Now, OSI model. Open system, interconnect. It's not an operating system, it is open system. Irrespective of what type of devices you are using to connect, what type of protocols you are using, or what type of what we can say cables you are using. Okay, what operating system you are using, what hardware you are using, okay, what model you are using. This is OSI model is a kind of network model. Okay, explains any kind of network model. It explains any kind of network model. So this is called as a reference model. Means really we didn't implement this OSI model in a real time, but purpose of this model, it's like a different protocols, different things are there in here. The purpose of this model is to understand your network, how it is communicating, how we are communicating, understanding of network. Next one is for mainly troubleshooting. Okay, understanding, troubleshooting, maintaining, or last one is also help to creating network. Okay. So our understanding of network, troubleshooting network, maintaining of network, or creating new network. I'm adding creating also, creating network. So understanding of network, troubleshooting of network, network related issues, maintaining of network. This OSI model is useful. That is the first. It is 7-layer model. This model is called 7-layer model. Okay. And still now it is still people are in that specific mind because it is a standard model. Standardized by ISO, International Organization for Standardization. International Organization for Standardization. It is standardized this model, so it is all in one model type. Okay, so these are the about some basics of OSI model for mainly understanding, troubleshooting, maintaining, and also you can create your different network models or network things using this. Now your duty. What is the, tell me, layers, guys. Application layer, then
Presentation layer,
Presentation layer.
presentation layer, session layer, then
session layer, transport layer,
transport layer. Very good.
Network layer.
Very good. Network
Data
layer, data
link.
link layer.
Physical layer.
Very good. Physical layer. The layers are 7 layers. So the from bottom it is like a physical layer is first layer, data link layer is second layer, network layer is third layer, session layer is, so transport layer is fourth layer, session layer is fifth layer, and presentation is sixth layer, and application layer is seventh layer. All these 3 layers, the bottom 3 layers, we call it as hardware layers, and remaining are software layers. The transport layer is also called as, okay, heart of OSI. Okay, heart of OSI. It provide end-to-end connectivity. It also do error correction. Error correction. These three layers is hardware layers. But really it's not like that, depends upon the connectivities. Okay. Example of physical layer is hub. Example of data link layer is switch. That's why switch is called as a layer to device. Okay. Network layer. It is, the example is router. So all these are all hardware layers, and bottom layers are hardware layers. But this network layer part also our system will do it. It depends then how you are connecting. So that's why it is like application, presentation, all session layer. So all these things are software layer. So these are the 7-layer model. As I said, like earlier, so I changed the explanation of this OSI model. Okay, but I didn't do it. I directly given a different direct explanation of each and every layer. But think like this, guys. Just listen first as a little story kind of stuff. Then I will explain. I don't explain. Just I will give you points on everything. Okay. So each layer of things we'll see once again. So I will tell you first a small story, then try this. Okay. You don't know anything about OSI model. Forget about first OSI model, layers and all. Leave about it. Okay. Leave about it. Your OSI model. Okay. You don't know anything about OSI. Okay. OSI or a network. But we are all using network, right? We are all using daily, we are browsing. Okay. You're watching YouTube videos, Facebook, or maybe Instagram, okay, WhatsApp, Gmail, Yahoo Mail, okay. Different things, different website, w3schools.com, javatpoint.com. So different things we are accessing daily, right? We don't know anything OS and all. So from that angle, I will see. For example, I want to access a site as like a, for example, w3schools.com. Okay, I want to learn some information from w3schools.com. Then what I have to do? Can I go to the command prompt and type w3schools.com here? Can I put it in my web browser? Sorry, put it in an Explorer. Or maybe I open a VLC player or putty. Where can I, how can I access this? w3schools.com website or gmail.com or facebook.com. How to access? Tell me. I think you didn't understand my question. I want to access facebook.com, linkedin.com, youtube.com. How to access? I got some computer right now. How to access it? I want to see that data. So I want to read something from javatpoint.com. Or I want to send a message through Facebook. Or I want to watch a YouTube video. What I have to do? Of course, I have internet. That is also we'll discuss. Tell me. Everybody knows answer.
Should have a browser.
Very good. First, you have to open the browser. It can be any browser, right? Maybe Google browser, or maybe what is this Microsoft Edge browser or Firefox browser. Yes, very good. First is open the browser. And which one you want to learn? So, for example, javatpoint.com. I want to learn about Python. Okay, and I am reading what it is, the content, right? So what happened? I use an application. Okay, I'm using an application to connect to the specific website. To access a website, that web browsers are required, not a command prompt, not a putty, or not a some other VLC player, right? I want to access web-related content, so then a web browser is required, right? Understand that point, guys? I need a application. Okay, this is application. What type of communication and what application for that type of communication? What application you use it? Okay, I want to access my remote Linux machine. Then I open this putty. I type that my Linux machine IP address here and what type of connection SSH or telnet. Then click on open. Then I will access remotely. I will connect it. I can access it. I can use it. This is a application for connecting purpose, right? And this is protocol. Okay, this is an application used to access a website, web address, and protocol. So this is a web-related communication, that is remote access communication. Okay, so different types of communications. I open Outlook. This Outlook is for mail-related communication. Outlook is used for mail-related communication. Okay, I can able to send a mail. I can able to receive a mail. Our Teams. Teams are used for so different types of communication. Screen sharing, audio, video, or a text messaging purpose. Different types of communication. So depends upon different types of communication, different applications we use it. And based on the what type of communication, that protocol we use it. Okay, first part understand, guys.
Yes, sir.
Okay,
Yes, sir.
next. So what is, I'm going back to the old kind of stuff, but again, application layer is about application. Example is a web browser. First example is web browser. Okay? Google Chrome, Microsoft Edge, anything. It's a web browser. One second. Sir. Okay, sorry, just important. Yeah, where are we? Application. It's all about server. Okay, these applications are about server or client side applications. Okay, client side application. Example, web browser at our side, Outlook. Okay, Outlook is one of the mail client application. Okay, and web means is like I told you, Tomcat. Tomcat is also like a Microsoft IAS is a server side application. Okay, and Microsoft Exchange is a mail server. It is okay. So these two are a client. These are the server side application. So what type of communication? So based on the types of communication. So what you have to do, that application you are using, in that application, so what type of communication, what communication you are doing? So it is the protocols. How you, the application understand what type of communication you have to do it. Okay. So based on the protocol only you are doing communication. So protocols is also part of this application layer. Why I given a gap? Okay, no problem. Okay. Hmm? You still am muted or what? Okay, unmuted. Sound, are you able to hear?
Yes, sir.
Yes, sir.
Okay.
Yes, sir.
I think voice is permanently cut. Okay, good. Okay. Next, presentation. So I open data. So I'm accessing data, right? So when I'm sending a request, I'm getting data, right? I'm sending a mail and I'm receiving a mails. Okay. I'm sending mails and receiving mails. I've opened a page and I'm able to read it, right? I'm getting that from server to here. I'm watching a YouTube video. Okay. I'm uploading a video. I'm watching a video. Okay. This document, I am able to read the document. I'm able to add the document things and it is got uploaded, right? So it is sending and receiving. While you're sending a data may be having a bigger the size and different formats of data is also there. See, this is a normal text data, but this is a video data and this is another text data and there is some pictures also there. Okay, HTML type of data. In WhatsApp, we are sharing links, right? In WhatsApp, we are sharing different links in it, pictures inside, okay, videos, right? We are sharing different types of content. Okay, mails, PDF you are sharing, right? Mail data is there, PDF links, different data we are sharing. And this is also some video integration inside. So different data we are transmitting from source to destination and then destination to source, right? Different data has to be encoded. Okay? So encode and decoded means it converts. It convert data in different formats. Example, PDF format, okay, JPG format, like pictures, PNG format, JPG format, DOC format, okay, PNG format, MP3 format, MP4 format, okay. So different format of data into American Standard Code for Information Interchange. Okay. Encoding, decoding. So what is the next one? Compression and decompression. And compression and decompression. That is, it compresses the data to reduce size. Compression, decompression. Next. Encryption, decryption. Okay. So when you are sending, it encrypt the data to secure, okay, secure the data. Okay. While you are sending the data. Okay. So this is presentation layer. Next. Session layer. Session layer, again, two things. It starts the session. Okay. So when you are open this, okay. So when you are open this, what happened? From my side, a session is created. And it is sent up to, means the request sent up to the that Java T-point server. And I am getting a reply from there to here. Data is completely loaded. Till the time session has to be maintained. Means it's create a session has to be created. So create session, maintain the session, and terminate. Okay, terminate the session. It means once data is loaded or uploaded, sent, okay, connected, so the session is completed. Example, you scan the QR code. You are purchasing some item. So you open it, you scan it, you enter the data, you enter the amount, you enter the bank details, and you send, and your transaction is completed. You got a transaction is successful. This is the result of transaction. Till the time the session has to be maintained. Once completed, session will be terminate automatically. Okay, that is a session. Can handling multiple sessions at a time. Handle multiple sessions. So different sessions in a one single session. Maybe there is a multiple request in this session, multiple requests in a single session. Also there multiple request session. Okay, next authentication and authorization. Okay, these are the responsibility of session layer. Okay, so guys, every session has PDU. Means every session data is called a PDU. So here I open a data here, here, or here. This, what are the data in this layer, in this application? So the data is, we call it as a data only. That we call it as a packet data unit is data in the application layer. Okay. Same. The PDU is data. PDU is also called here in presentation layer data. In presentation layer, what are the data in the application layer will be encoded, compressed, encrypted. Even that is, there is so many changes inside, there is a, we call that one as a data, that PDU. Okay, after formatting, also it is the data, we call it as the PDU is our data. Session layer. In a session is created. Okay, and it is include authentication and authorization details. Authentication and authorization information is also added. So that data we call it as still it's a data only. We call that one as a data only. Okay. Now transport layer. Anybody can tell what is transport layer? What it will do? It segment the data. What are the data it is? It chopped into the small pieces. It segment the data. Numbering and sequencing. Numbering and sequencing. It apply numbers on the segments of data. Segments of data. TCP and UDP. Okay. Port multiplexing. Okay. Multiplexing or encapsulating also you can say. One more is there, that is called a windowing or flow control. Error correction. So this is the responsibility of transport layer. Okay. From transport layer, what are the PDU you got it? That is the PDU, we call it as a segment. So small change, I will removing this PDUs. Guys, it's because it is taking more space than required. Okay. So the PDU means packet data unit. PDU means packet data unit. PDU means packet data unit. PDU means packet data unit means layer data. After processing in the layer, outcome of layer process data is PDU. In application layer, what is the data out after the application data connectivity protocols? That we call it as a data only. And after encoding, compression, encrypting of the data, so that the resultant is the PDU is called the data again. It's same for the session layer also. But in a transport layer, data is no longer data. Data is segmented. It's chopped into small pieces. And on the data, it is numbers, numbering sequence order is added. TCP, UDP ports are added. TCP, UDP port numbers are added. Okay. TCP, UDP port numbers are added to your data. Okay. Next, flow control. Flow control means number of segments your send. That is flow control. Means number of segments you are sending at a time. Error correction is possible. So these are all things are added and changes to your data. So that PDU we call it as a segment. Guys, understand? Or just next time I'm keep on telling and the thing. Okay, it's afternoon time. That's why it is like that. Okay. Yeah, next. So for this segment is how the segment is created also is important, right? TCP, sorry, segment on a segment. So we'll keep it like that only. We're going to add new line here. In transport layer, actually, what happens? There's a TCP header plus your segmented data. Okay. So this is what we call it as a segment. So that is in a TCP header, it contains information about flow control, TCP, UDP port numbers, okay, sequence number is there. Network layer. So what happened to the network layer? In network layer, routed protocols means logical addressing means for us it is IP address. There is a lot of different routed protocols are there, and it is there. Next is routing protocol. Like RAP, EIGRP, OSPF. Okay, these are different routing protocols. Point is not one. Routed protocols means it will adding what it is, source IP address and destination IP address will add. Routing protocols means it will add routing information. Routing information means best path or path to reach destination. Path to reach destination. AN. Okay. So what happened here, guys? To your segment, the segment sent to the network layer, to your segment, source IP plus destination IP is added to your segment from network layer. The resultant we call it as a packet. Means from network layer, what we are getting is packet. Okay, what we are getting is packet. Remember this thing. Transport layer. From transport layer, we are getting segment. and segment sent to the network layer, and in network layer, source IP, destination IP added to your segment. That is called packet. Means network layer outcome is packet. Guys, understand? Again, everybody is silent. Okay. 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 In data link layer, two layers are there again, sub layers. One is LLC layer, logical link control. Earlier upper layers are more like a software layers type, but bottom layers like the MAC layer and physical layer are a hardware layers. Some people saying the logical link control make a connectivity between the upper layers, means from network layer to that hardware layer parts, means your NICs, okay, connectivity. It is actually making a link between them. Means it is controlling communication between this top layer, this layer to these layers. So in some textbooks, some people are saying like that. But as I know, this is WAN protocols are there. Okay. You can also say like that. Okay, no problem. It is logical link control. It means it create a logical connectivity between this network layer to the bottom hardware parts. Okay. So that is it is make a connectivity is logical link control. And another way it's a WAN protocols works here. WAN protocols. What are the WAN protocols? Under logical link control works with the WAN protocols like PPP, point-to-point protocol, PPP OE, okay, or Ethernet protocol. You take ACT, PPP OE, okay, and GPON, fiber net kind of protocols now, okay. So one frame relay, DSL, ADSL, DSL, ADSL. MPLS. This is a new technology, not a new one, guys. It is 10 years back technology only. Okay. But this is currently using internet technology, means WAN technology is MPLS. Again, on top of MPLS, because MPLS is implemented so many years back. So, and this is a new SD-WANs. Okay. Software defined wide area networks. It is mixture. It's not a hardware related. Okay. It's completely software related WAN protocol type. Means combine this MPLS and other types of uh, broadbands or WAN technologies. Will combine everything. All types of WAN technologies, all types of WAN technology protocols, because MPLS is a multi-protocol WAN technology. Okay, remaining are just internet connection, just data connection type only. But MPLS is a multi-protocol, quality of service protocols are there. SD-WAN is combine all this type of things, and we can make it as one single boundary with the SD-WANs. Okay, so it's a new technology made. Yeah, we know media access control. Okay, of course we know the MAC address. The MAC address is nothing but a MAC address. It provide a MAC address. MAC layer give MAC address is called as physical address. Okay, physical address. Of course, we know it is 48-bit. Okay, represented in full hexa number. So what happened with the MAC layer is, guys, if you are connecting, you are sending data over WAN protocols, WAN protocol data will be added. If you are sending or in the LAN only, within the LAN only you are communicating within the same segment communication, MAC information is added. So right now we are thinking we are communicating in the LAN only. Okay, we are communicating within the LAN only. So in that cases, source MAC address, okay, source MAC address, and the destination MAC address, you'll add it to your packet plus CRC. So this whole we call it as frame. Frame. So from data link layer, what we are getting is frame. Then what is this? CRC. CRC is not a layer. CRC is a cyclic. What is CRC? Anyone? Non-speaking, everybody. CRC.
Yes, sir.
Cyclic redundancy
Yes, sir.
check. It's a kind of algorithm. Okay. What it will do, generate a check some data purpose is error detection. Okay, detect error. So data link layer detect error, any errors in the data. So that checksum error will be added to this data. So total we call it as a frame. So we are reaching last. In physical layer, the frame is converted into bit stream. Okay, the physical layer provide physical connectivity. That is wide type of connectivity or wireless type of connectivity. Okay, wide type or wireless type of connection. First, okay, connectivity means so based on connection, it converts bit stream into the related signal. No, it's not so. Okay. Related signal means you are using Ethernet with a net NIC, with a type of NIC means UTP cable or STP cable. Okay, and data will be electrical signal. Okay, HBA, host bus adapters, type of NICs, which means it's a fiber optical cables. We use it. The signal is light wave. Radio, Wi-Fi, wireless type of NIC, Wi-Fi based NICs. Okay, so Wi-Fi based connectivity means it's a Wi-Fi signal. Wi-Fi bands like 2.4 gigahertz and 5 gigahertz. Okay, it's called radio signal. Okay, Wi-Fi based NICs means what type of connectivity? Different frequencies like 2.4 connection, 5 gigahertz connection, radio signals here. Okay, so actually it is 2 points are there in a physical layer. So one is bit stream. Okay, the frame is converted to bit stream, then it is converted into different signals. Depends upon the signal to convert. So this is your OSI. Okay, guys, understand? So what is importance? Each layer, what it will do. That is very important for each layer. And each layer, data, PDUs are important. Transport layer, segment, network layer, packet, data link layer. After data means after processing, frame. After physical layer, it's a bit stream. Again, it will convert into different signaling formats. That is a very important one. Okay. And of course, what it will do. Okay, what is the explain about presentation layer? Explain about application layer. Application layer means server or client-side applications and protocols. Presentation, encoding, decoding, compression, decompression, encryption, decryption. Who got the question on the presentation layer? Happily they can tell. No confusion at all inside. Okay. No lengthy, no shorter. 3 points, 3 clear-cut points in it. Session layer. So create a session, okay, and maintain the session, handling different type of sessions, and works with the session ID. Session ID is also there. Okay, create a session means it creates a session ID. Transactions will complete in that session ID only. Okay, so we'll remove this one. Create a session, the session ID, maintain the session till the session is completed and terminate the session once it is completed. Authentication and authorization. When you are giving a request for like a sending mail or receiving mail, web related, so you have to send your email password, right? That some authentication is required to get it, right? So some authentication. Nothing you are not specified means it is anonymous authentication. Okay, different authentications. Authentication means identity, verification of identity. Authorization means, okay, permission to access, allowed or not, authorized, you are authorized to access or not. Next, transport. It segment what are the data from these top 3 layers. Here it is, it segment, it chop the data into small pieces. Each piece, it is assigned some number in the sequencing order. Okay, it take your TCP UDP port numbers, protocols port numbers will be added to your transport layer information. Okay, TCP UDP protocols will be added here. And how many packets you are sending, how many segments you are sending, that information is also added here. And error correction is because of TCP UDP, so acknowledgement based. So based on that, it is error correction is there. So all this information means your data segment, the segmented data, plus your TCP header, which contains your TCP UDP protocol information. Okay. And now the segmenting information, segment sequence and numbering information is added to this TCP header and to your segmented data. So the total whole we call it as a segment. Segment sent to the network layer. The network layer, so when you are sending, you have to add your source IP, destination IP is added to your segment. So this is called a network header. Okay, network header, that is TCP header. This is network header. This is a network header. Network header is source IP, destination IP to your packet. Then this is sorry to your segment that we call it as a packet. So what is outcome? PDU of network layer is packet. Packet sent to the data link layer. In data link layer, source MAC address, destination MAC address is added as a header, and CRC, cyclic redundancy check, as a tail. So this is data header, data link layer header. This is header. This is tail. Okay, this is data header. This is tail. Data header, we can say this is data header. This is called data tail. CRC. CRC is a checksum data. So of your actual data, CRC is used to error detection. Any issues are at in the CRC destination. And total we call it as a frame. So data link layer outcome is frame. The frame sent to the physical layer frame is converted to bit stream. Again, this bit stream is converted to as per your connectivity. So different signals it will be converted. Electrical, light wave or radio wave signals. Okay. You guys understand? No, no speaking.
Yes, sir.
In yeah, tell me. In generally, when we are discussing about a transport layer, there is a TCP UDP multiplexing is there. Means TCP protocols, UDP protocol, port numbers will be added into the your TCP header. Then generally people will discuss, even myself also will tell about a TCP UDP information is there. But I am separating this TCP and UDP separately. I want to write because it is also one question. What is the difference between TCP and UDP? Anybody will tell TCP abbreviation?
Transmission Control Protocol.
Very good. UDP.
User Datagram Protocol.
User defined.
Very good. Why I'm typing before you are telling without waiting, guys? We are all knows. Problem is instantly we can't recollect it that time. So just time sometimes. Okay. So that's why I'm typing. So you have to catch. So line is repetition is the only one thing we can remember. This. Okay. Transmission control protocol, user datagram protocol, two protocols. Okay. What is this TCP UDP? we discussed about different protocols, right? That's why I separated everything. We discussed about different protocols. Okay. Here the point is the protocols are can be TCP type protocol or UDP type protocol or both. Okay, it can be TCP type as well as UDP type. Example of TCP type protocol: HTTP, HTTP, HTTPS, FTP, SMTP. Okay, so these are all TCP type protocols. Okay, UDP type protocols. Example, TFTP. So TFTP is UDP protocol. DHCP UDP protocol. DNS UDP protocol. DNS is TCP type as well as UDP. That's why I've written both are in the same place. Okay, both are in a like that only I written. TCP type protocol, UDP type protocol. Transmission control protocol, user datagram protocol. Okay, so these are some are TCP type protocol, some are UDP type protocol. Okay, so again, TCP type protocols are reliable protocols. It's a reliable protocol. UDP are non-reliable. Non-reliable protocol. Okay, so non-reliable protocol. TCP are connection oriented. UDP are connection plus. Connection oriented means it check the connectivity whether destination is there or not. First, in a TCP type of transmission, check the destination is there or not. Then only it transfer the data. Once it is send the packet, so it will try to receive the acknowledgement. Acknowledgement based communication. It is no acknowledgement. No acknowledgement here. So here in this TCP, source and destination. Okay, first it is establish connectivity between them. Source and destination, it check the connectivity. Okay, is it destination is available or not? Next, it will send a packet first. Destination is received a packet. Then destination will send a acknowledgement for that. Okay, it will send a acknowledgement for that packet. So destination received, source received a acknowledgement from destination. Think destination is received the packet. So whenever the source send a packet, destination received a packet, it will give a acknowledgement for that packet. So source knows destination is received a packet. So what I have done, the third packet, so the source is not received any acknowledgement, but fourth packet it is received an acknowledgement. Okay, it's keep on sending, it keep on receiving acknowledgements. So it is thinking third packet is not received by destination. That's why it is not receiving acknowledgement for it. Again, it will send it. It's a kind of error correction only. So error correction. Error correction means any packet is corrupted or any packet is dropped, any packet is missed. So it will send the packet again. So that is called a error correction, transport layer. So this is how happens at user service, TCP. In UDP types of protocols, it won't check any connectivity. It's not a connection oriented type. It send the packet, so destination will receive the packet. Okay, destination is received the packet. Even destination is received or not, we don't know. Okay, even destination not received a specific packet, still we don't send again until unless there is a error throwing from destination. Okay, so here it is slower than UDP due to acknowledgement, faster than TCP type protocols. Okay. So due to no acknowledgement. Okay, so that's the difference. Slower and faster because of this acknowledgement. And see, it is I'm doing some 3 to 4 communications in between. In the bit, by the time I have done almost like a more than 8 packets are sent. Even destination not received a packet. So we don't worry, we are keep on sending. Of course, we'll repeat while repetition, again it will rearrange the data. This is the difference between TCP and UDP. Okay, guys, TCP UDP now can we tell in the interview this type question?
Yes, sir.
Okay, good. So last in this part, TCP IP protocol suite is a protocol suite. It means so actually we are using TCP IP protocol suite only. Okay, and so it is came from DoD model. Okay, it's a Department of Defense or a Defense Department. Okay, Department of Defense. Okay, from this Department of Defense model is a framework describing network used to create transmission control and internet protocol. Okay. It is simpler than OSI model, but it is actually say TCP IP model came from this DoD model, Department of Defense model. Later, it is become public. public use. Earlier it is used in only the defense places only, not in Indian defense. Okay, US defense places are there. All inventions for a defense purpose. So later it is the scientific departments are splitted and go with the different interests. Like some are for satellite related communication, separate exploration, scientific related things are changed. But earlier days, it's all things must be work for a department, even computers, programming, okay, this mathematics, physics, yeah, all things works for a department of defense. Okay, from this one, they created one model called the TCP/IP model, different Department of Defense model it is. Okay, later it is went to the public with the TCP/IP model. It is earlier than OSI model, guys, but it is simple than OSI. So there is a simple 4-layer model. It is only 4 layers. The first is your application layer. Next is transport layer. Okay. Another one is internet layer. Last one, network access layer. Okay. If you are comparing with the OSI model, in a OSI model, you have an application, presentation, and session. All these things will be done by your session layer only. Means in a application layer only. So when you open application, like you are open your Zomato or Swiggy, so automatically session is started with your network, whether it is 4G network or Wi-Fi. So and your application, what you open, so session is created. And what are the data is encrypted, decrypted, all these things in your application based on application only to act. Okay, it happens at application level only. Protocols, port numbers, okay, encryption, decryption, compression, okay, all this session creation, session IDs, everything is at application layer side only. Transport is the transport. Okay, transport is always a transport, separate transport layer is a transport only. Okay, so transport layer is what are the data is segmenting, adding a TCP, UDP, port numbers to your segments. Okay, flow control, number of packets you are sending, flow control, and error detections. Okay, sequencing numbering, TCP, UDP protocol separations, port number separations are by transport layer itself. Then internet layer comes. Internet layer is nothing but your network layer. Okay. What is the network layer do? Source IP, destination IP, and tell how to reach the destination. Okay, best path to reach the destination or path to reach the destination. You can say. Network access layer. Network access layer is data link layer and physical layer. Okay, two details. Adding a MAC address or and convert the data into different formats. You have NIC card, right? NIC cards are there. It actually comes under network access layer. Okay. What is start point? You guys understand the comparisons?
Yes, sir.
Yes.
And very. We are using TCP IP protocol. A TCP IP model, simple TCP IP model only we are using. Next one, what happened? Okay, TCP IP protocol suite. TCP IP model. Next UDP or STP cables we use to connect generally for wide type of connectivities. TCP UTP cables we use it, not even STP, but mainly use TCP type of cables we are using it. Okay. Next. So we discussed a lot of things. So in a models, TCP IP model, in cables, topologies, star topology we use it. But we use star topology we use it. Okay. Hub switches, modems, routers, all we use it, all together Wi-Fi router also we are using it. That's a different point. Okay. So what we are using is this part. We don't use fiber optic cables in LAN communication. We don't use mesh topology or ring topologies in LAN in our communication, right? We use star topologies. We don't use OSI or IPX, SPX, different protocols are there, SPX, IPX, okay, Apple Talk, different protocol suites are there. What we are using is TCP IP model only. Protocol suite is TCP protocol suite. Yeah. So by this, what are we discussed till the last 3 days, that those last week 3 days are completed in the 2 days of 1.5 day sessions. Okay, that is. Now, in the next after break, so we're going to complete this all parts by taking few things. It is important one is also there. SOHO, I didn't repeat that SOHO right now, but we'll discuss things is like about a few of the networking related commands and then troubleshooting using OSI model with a network, some troubleshooting things like ping, trace RTs. In a ping replies based on that, how you will understand, how you will communicate. Okay, that kind of stuff. And how to create a network like Wi-Fi router connectivity. Okay, how to configure Wi-Fi router, changing of Wi-Fi router passwords. Also, we'll see. We didn't repeat this one. How to configure a IP address. Okay. The next part, along with that one, we're going to discuss that. Okay. Take a small break, guys. Come back at 4:30. It's already 4:17, so take a 15 minutes. Okay. Come back at 4:30. Take a small. Take a break.